Okay, we're going to do a quick preview of the lesson P.7, solving inequalities algebraically and graphically. We're going to start with an absolute value problem. Just remember, before you start solving an absolute value problem, you're going to have to get the absolute value alone. So I'm going to subtract the 2 from both sides, which will then give me absolute value of 3 minus 2x is greater than 3. Okay, keep in mind absolute value splits up into two cases. The first one, you remove the absolute value and you leave everything alone. The second case, you remove the absolute value, but then you switch everything on the other side. So what was a greater than becomes a less than. What was a 3 becomes a negative 3. Okay, and you can solve both of these. And here are the solutions, just to save time. If you want, you could pause the podcast. Now we need to write this in interval notation. Before we do that, it might be useful to first graph it just to see what's going on. Here's 0 and here's 3. Notice that when x is less than 0, open circle, less than implies we go that way. For the next one, when x is greater than 3, open circle, goes that way. So how would we write this in interval notation? Well, we would say from negative infinity to 0, and then from 3 to positive infinity. Okay, that's our answer for this one. And sometimes it's good to put union. Next problem is similar. I'm going to do it over here because it's a little bit out of space. So the first case is just x minus 5 over 4 less than or equal to 6. In the next case, x minus 5 over 4 greater than or equal to negative 6. Okay, and you can solve both of these. And here are the solutions. And if you were to plot it on a number line, what you would find, negative 19 there, 29 there, is that both of these will meet in the middle. So it's the interval in between. And since it's closed, it's going to go bracket, negative 19, comma 29, close bracket. Okay, same as the other one. Okay, this next problem is asking for where is this less than or equal to 0. Notice one thing I could do right away is I could factor this. I could pull out an x, which leaves me with an x squared minus x minus 30. Where is that less than or equal to 0? Okay, I can factor this part even more to be x minus 6, x plus 5. Now, a good thing to ask yourself is not where is it less than or equal to 0, but if we just worry about where it's equal to 0, it'll actually help us. So this is 0, this is 6, and this is negative 5. Okay, why does that help us? Let's just plot the x's on the number line. Okay, negative 5, 0, and 6. So I know at these spots that the function equals 0, but what if I want to know what's going on in between? Well, if you think of this as y, what we can actually do is plug in some numbers in these intervals, and what these do is they break up the intervals a little bit. So for example, if I plug in negative 6, the only thing I'm really caring about is whether it's a positive or a negative number. If I plug in negative 6, it turns out this is negative, this is negative, this is negative, so overall it'll be negative. If I plug in a number between here, say negative 2, turns out this is negative, that's positive, so overall it'll be positive. Right? So this will be a negative, this will be a positive. Similarly, in between here, let's say I plug in 1, it turns out that'll be a negative. If I plug in a number here like 10, it'll be a positive, right? Negative, positive. So let's look at the question again. The question is just asking, where is this less than or equal to 0? Less than or equal to 0 assumes negative. So the only spots where it's negative is going to be here. So I will write that as negative infinity to negative 5. And here, 0 to 6. Okay? Actually, because it's closed, these should both be brackets. Okay? The next problem is similar. However, the issue is that I can't factor this cleanly. So what I can do is take a graphing calculator, and I'm assuming everyone has a graphing calculator, and I can graph this. Turns out if you graph it on the graphing calculator, what the graph will look like, it'll be something like this, roughly. Okay, so it'll be a cubic graph. Let's look at the question again. Let's view this as y equals. So y equals, and I want it to actually be less than 0, which again assumes negative. So all I have to do is look at when the graph where it's negative, where y is negative just implies where is y below the x-axis. So it looks like it's this area and then the rest of this area. So how would I write this? Well, since it's less than, it's going to be open bracket, negative 2.06, all the way to here, 0.13. And then this part is going to be 1.93 all the way to infinity. Okay, if you want to think of it as a sign chart, it's above the axis here, so it's positive. It's below here, so it's negative. It's above here, so it's positive. It's below, so it's negative. Okay, and in relation to the previous graph, I know we didn't graph it, but if you were to graph this, what it would look like is something like this. Okay, and again, you can see it's below, it's above, it's below, it's above. That's how we get our answer. Okay. Your homework problems are going to be these three. Solve the absolute value problem. Solve this. You can try factoring or graphing. Same thing here, factoring or graphing. Don't forget to move the 4x before you do anything.